The Infinite Canvas. A journey into the multiverse. Imagine standing at the edge of a vast, starry night sky. Each pinprick of light represents not just a distant sun, but an entire universe. Endless worlds beyond comprehension. Gaze upward, and you might feel the weightlessness of insignificance or the exhilaration of infinite possibility. What if every decision you've ever made has created another version of reality? Every choice, a fork in the road, a whispered yes instead of a hesitant no, has spawned a new timeline, a parallel existence where things unfolded differently. This is the starting point for our journey into infinite universes and the existential dread they inspire. To begin, let us consider the sheer scope of what we're discussing. When we talk about infinite universes, we aren't merely speculating about faraway galaxies or alien civilizations. We are delving into the idea that everything, every possibility, every variation, every conceivable outcome is happening somewhere. It's as though the cosmos itself is a boundless canvas, stretching infinitely in all directions, each brushstroke representing a unique configuration of matter, energy, and consciousness. On this cosmic stage, your life and mine are but tiny fragments of an unimaginably grand narrative. The concept of infinite universes isn't just poetic imagery. It stems from rigorous scientific theories like quantum mechanics and the multiverse hypothesis. At its core, the multiverse theory suggests that there are countless parallel realities branching off from every moment of decision, every quantum event, every infinitesimal shift in the fabric of space-time. These alternate universes coexist alongside ours, unseen and unreachable, yet real in their own right. Think of it as flipping through an endless stack of books, each page telling a slightly different story of your life. In one universe, you took the job offer you turned down. In another, you never met the person who changed everything. Somewhere out there, perhaps, exists a version of you who won the lottery, or one who never learned to read. This notion challenges the way we think about existence. If every possibility exists somewhere, then what does it mean to make choices here and now? Does free will even matter when all outcomes already occur elsewhere? To explore this question further, we must unpack the implications of living in a multiverse. At first glance, the idea of infinite universes may sound absurd, even fantastical. Yet, it arises from some of the most well-established principles in modern physics. Quantum mechanics, which governs the behavior of particles at the smallest scales, provides fertile ground for such speculation. One interpretation of quantum mechanics, known as the many-worlds interpretation, posits that every quantum event spawns multiple branches of reality. For instance, when an electron passes through two slits in the famous double-slit experiment, it doesn't choose one path over the other, it takes both, creating two separate realities in the process. Multiply this phenomenon across trillions upon trillions of particles, and you arrive at the staggering conclusion that countless universes are constantly splitting and diverging. But the multiverse isn't confined to quantum mechanics alone. Cosmologists have proposed various models of the multiverse based on different aspects of theoretical physics. Some suggest that during the Big Bang, space-time expanded so rapidly that regions of the universe became isolated from one another, forming distinct bubble universes. Others propose that higher dimensional spaces, such as those described by string theory, could contain entirely separate realms with their own laws of physics. While these ideas remain speculative, they underscore the profound mystery of existence. Is our universe unique, or merely one among many? What makes the multiverse hypothesis so compelling and unsettling? is its ability to reconcile seemingly contradictory phenomena. Take, for example, the fine-tuning problem. The physical constants governing our universe appear finely tuned to allow for the emergence of life. Change any one of them by a fraction, and stars wouldn't form, atoms wouldn't bond, and consciousness would be impossible. This raises the question, why is our universe so perfectly suited for us? The multiverse offers a potential answer. If there are infinite universes, each with different parameters, then it's statistically inevitable that at least one would support life. We happen to inhabit that lucky universe because, well, we wouldn't exist otherwise. However, the multiverse hypothesis also invites philosophical unease. If every possible outcome occurs somewhere, then nothing truly matters, not triumphs, not tragedies, not even morality itself. After all, whatever happens in one universe is counterbalanced by its opposite in another. Your greatest success is mirrored by failure elsewhere, your deepest love overshadowed by indifference in a parallel world. Such thoughts can lead to existential paralysis, a sense that striving for anything is futile when infinity renders all efforts meaningless. Nowhere is this tension between awe and despair more palpable than in the emotional response elicited by the multiverse. Contemplating infinite possibilities often leaves people feeling simultaneously empowered and diminished. On the one hand, the multiverse expands the horizons of human imagination, offering a vision of limitless potential. On the other hand, it confronts us with our insignificance in the face of eternity. How do we reconcile these conflicting emotions? One approach is to embrace the paradox. The multiverse reminds us that while individual lives may seem fleeting and inconsequential, they are part of a much larger tapestry. Consider the analogy of a single brushstroke on a painting. Alone, it may appear insignificant, but within the context of the whole artwork, it contributes to something breathtakingly beautiful. Similarly, our actions, no matter how small, play a role in shaping the intricate web of existence. Even if alternate versions of ourselves live out different stories, the choices we make in this universe still hold meaning, for us and for those whose lives intersect with ours. Another perspective comes from reframing the concept of free will. Critics argue that if every decision spawns a new universe, then free will is an illusion. But what if freedom lies not in controlling outcomes, but in experiencing the richness of possibility? In a multiverse, every choice becomes a gateway to new adventures, new relationships, new ways of being. Rather than seeing ourselves as trapped by predetermined paths, we can celebrate the infinite diversity of experience available to us. Of course, grappling with the multiverse also requires humility. Acknowledging that we are but specks in an incomprehensibly vast cosmos can be humbling, but it need not be disheartening. Instead, it can inspire gratitude for the privilege of existing at all. Out of all the possible configurations of matter and energy, you and I are here, alive, aware, capable of wonder. That fact alone is miraculous, regardless of whether infinite duplicates of us populate other dimensions. As we ponder these questions, let's zoom in on one of the most famous paradoxes tied to the multiverse, the thought experiment, known as Schrödinger's cat. Imagine placing a cat inside a sealed box along with a radioactive atom, a Geiger counter, and a vial of poison rigged to release if the atom decays. According to quantum mechanics, until someone opens the box, the atom exists in a superposition of decayed and undecayed states, and thus, the cat is simultaneously alive and dead. How does something so small encapsulate such monumental ideas about existence. Schrödinger's cat forces us to confront the strange interplay between observation and reality, raising profound questions about the nature of consciousness, causality, and the boundaries of the self. As we delve deeper into this paradox, we'll uncover connections to the multiverse that illuminate both its beauty and its terror. Schrödinger's cat and quantum superposition, a paradox that challenges reality. Imagine a cat, calm and composed, sitting inside a sealed box. Unbeknownst to it, the box contains a vial of poison rigged to release based on the random decay of a radioactive atom, a quantum event that occurs unpredictably. Until someone opens the box to check, the cat exists in what physicists call a superposition, simultaneously alive and dead. Sound absurd? That's precisely the point. Erwin Schrödinger devised this thought experiment not to advocate for undead cats, but to highlight the bizarre implications of quantum mechanics, a field so counterintuitive that it challenges everything we think we know about reality. At first glance, Schrödinger's cat seems like an exercise in philosophical mischief. Yet beneath its whimsical exterior lies one of the most profound insights into the nature of existence. The paradox forces us to confront questions that ripple far beyond the confines of the box. What does it mean to observe something? Does reality exist independently of our perception? And if every observation splits the universe into branching paths, as some interpretations suggest, then how many versions of you are scattered across infinite realities? To fully appreciate the weight of Schrödinger's thought experiment, we must delve deeper into the principles of quantum superposition and explore their implications, not just for physics, but for our understanding of consciousness, choice, and the multiverse itself. At the heart of Schrödinger's cat lies the principle of quantum superposition, a cornerstone of quantum mechanics. To grasp this concept, let's step back from the cat and focus on the subatomic world where quantum rules reign supreme. Particles such as electrons or photons do not behave like tiny billiard balls with fixed positions and velocities. Instead, they exist as probability waves, mathematical descriptions that encode the likelihood of finding them in various states. For example, imagine an electron orbiting an atom. According to classical physics, you might expect it to occupy a specific location at any given moment. But in the quantum realm, the electron doesn't settle into a single position until it is measured. Before measurement, it exists in a superposition of all possible locations, described by its wave function, a mathematical entity that collapses into a definite state only when observed. This collapse is central to the Copenhagen interpretation of quantum mechanics, which posits that particles remain in superposition until acted upon by an external observer. In other words, reality isn't determined until someone, or something, looks. This raises profound questions. Who qualifies as an observer? Is consciousness required to collapse the wave function, or can any interaction suffice? And what happens to the unobserved possibilities once the wave function collapses? Schrödinger's cat amplifies these questions by scaling up quantum weirdness to macroscopic proportions. By placing a living being inside the box, he forces us to grapple with the unsettling idea that the cat's fate remains undecided until the box is opened. Until then, the cat exists in a liminal state, neither fully alive nor fully dead, but suspended between both outcomes. While the Copenhagen interpretation provides one way to understand superposition, another perspective emerges from the many worlds interpretation, MWI, which ties directly to the multiverse theory. Proposed by physicist Hugh Everett III in 1957, MWI offers a radical solution to the measurement problem. Instead of collapsing into a single outcome, the wave function never collapses. Instead, every possible outcome of a quantum event actually occurs, but in separate branching universes. In the context of Schrödinger's cat, this means that opening the box doesn't determine whether the cat is alive or dead. It determines which branch of the multiverse you experience. In one universe, the atom decays, releasing the poison and killing the cat. In another, the atom remains stable, leaving the cat alive. Both outcomes are equally real, existing in parallel realities that diverge at the moment of observation. The implications of this interpretation are staggering. If every quantum event spawns new branches, then the multiverse is constantly splitting, creating an unfathomable number of alternate realities. Every decision, every interaction, every flicker of uncertainty contributes to this cosmic proliferation. You aren't just reading these words in one universe. You're doing so in countless others, each slightly different from the last. But here's the catch. If every possibility exists somewhere, then what role do observers play in shaping reality? Are we passive witnesses to predetermined paths, or active participants in crafting the multiverse? This question leads us to the heart of existential dread inspired by quantum mechanics and the multiverse hypothesis. One of the most unsettling aspects of Schrödinger's cat, and by extension the multiverse, is the ambiguity surrounding the role of the observer. In the Copenhagen interpretation, observation collapses the wave function, suggesting that conscious awareness plays a crucial part in determining reality. But if this is true, then who or what counts as an observer? Must it be a human mind, or can machines, animals, or even inanimate objects serve the same function? Consider the box containing Schrödinger's cat. If no one opens it, does the cat remain in superposition indefinitely? Or does the mere presence of air molecules, photons, or other environmental factors trigger the collapse? Some interpretations argue that decoherence, a process by which quantum systems interact with their surroundings, effectively resolves superpositions without requiring conscious intervention. Under this view, the act of observation isn't special. It's simply the result of unavoidable interactions within the universe. However, the many worlds interpretation sidesteps the need for collapse altogether. In this framework, observers don't dictate reality. They merely experience one slice of it. Each time a quantum event occurs, the universe splits, and observers find themselves in one of the resulting branches. From this perspective, free will becomes a curious illusion. Your choices don't create new realities. They reveal pre-existing ones. Every version of you already exists, scattered across infinite timelines, making decisions you'll never see. This realization can evoke a profound sense of disorientation. If every action spawns a new universe, then what does it mean to make meaningful choices? Does morality lose its significance when every ethical dilemma unfolds in countless ways with no clear resolution? And how do we reconcile the uniqueness of individual experience with the knowledge that infinite duplicates of ourselves live out alternate lives? Contemplating Schrödinger's cat and the multiverse often brings us face to face with existential dread, the feeling of insignificance in the face of infinity. On one level, the multiverse offers liberation. It suggests that failure is temporary, success inevitable, and every dream achievable somewhere. Somewhere, you've written the novel you've always wanted to finish. Somewhere else, you've reconciled with a loved one you lost. In yet another universe, you've achieved feats beyond your wildest imagination. Yet this same promise of infinite possibility can feel suffocating. If every outcome exists, then striving for anything seems futile. Why work toward a goal when an infinite number of yous have already succeeded or failed? Why care about relationships, achievements, or moral obligations when they lack permanence in the grand scheme of things? These questions strike at the core of human identity. We yearn for meaning, for connection, for a sense that our actions matter. But in a multiverse teeming with endless variations of ourselves, how do we anchor our sense of self? One answer lies in embracing impermanence. Just because infinite duplicates of you exist doesn't diminish the value of your experiences here and now. Your joys, sorrows, triumphs, and failures are uniquely yours, shaped by the specific circumstances of this universe. While others may share your name or appearance, no one else inhabits your exact perspective, your precise blend of memories and aspirations. Another approach involves reframing the concept of free will. Even if every decision spawns a new universe, the act of choosing still holds significance. Each choice represents a fork in the road, leading to new landscapes and opportunities. Rather than seeing ourselves as powerless passengers in an infinite cosmos, we can embrace the adventure of navigating its twists and turns. As we grapple with the implications of Schrödinger's cat and the multiverse, a deeper question arises. How do we know any of this is real? If quantum mechanics reveals a reality that defies common sense, and the multiverse suggests infinite layers of existence beyond our perception, then perhaps the very fabric of reality is an illusion. Could the stars, planets, and even our own consciousness be nothing more than lines of code in an advanced simulation? This unsettling possibility forms the basis of the simulation hypothesis, which proposes that our entire universe could be a highly sophisticated computer program created by a higher intelligence. Proponents of the hypothesis argue that if civilizations reach a level of technological advancement capable of simulating entire worlds, it's statistically likely that we're living in one ourselves. The parallels between quantum mechanics and the simulation hypothesis are striking. Just as particles exist in superposition until observed, simulated environments might render details only when needed, conserving computational resources. Similarly, the branching paths of the multiverse resemble the nested simulations envisioned by philosophers like Nick Bostrom. Whether we're inhabitants of a cosmic choose-your-own-adventure book or characters in a digital game, the line between reality and fiction begins to blur. So, as we ponder the strange interplay between observation and reality highlighted by Schrödinger's cat, let's turn our attention to the simulation hypothesis. Is the multiverse merely a construct designed to mimic infinity, or does it point to a deeper truth about the nature of existence? These questions invite us to peer behind the curtain of reality, challenging us to discern what, if anything, is truly real. The simulation hypothesis. Are we living in a digital universe? What if everything around you, the air you breathe, the ground beneath your feet, even the thoughts swirling in your mind, is nothing more than lines of code running on an advanced computer? Imagine life as a highly sophisticated video game, where every action, every interaction, and every moment of existence is meticulously programmed by an unseen creator. At first glance, this idea might seem like science fiction or the musings of a late-night philosopher. Yet, when examined closely, the simulation hypothesis presents a compelling challenge to our understanding of reality. It suggests that the universe we inhabit may not be what it appears to be, but rather a meticulously crafted simulation designed to mimic the real thing. This concept forces us to confront profound questions about the nature of existence. If we are living in a simulation, then what does it mean to be human? What happens to notions of meaning, morality, or identity when the foundation of reality itself is called into question? Would knowing the truth empower us, or would ignorance truly be bliss? To explore these ideas, we must delve into the origins of the simulation hypothesis and its implications for how we view the world and ourselves. The simulation hypothesis was popularized by philosopher Nick Bostrom in his seminal 2003 paper, Are You Living in a Computer Simulation? Bostrom's argument hinges on three propositions, at least one of which must be true. 1. Almost all civilizations at our current level of technological development go extinct before reaching the capability to create realistic simulations. 2. Even if civilizations survive long enough to develop such technology, they choose not to run simulations of their evolutionary history. 3. We are almost certainly living in a computer simulation. At first glance, these options seem abstract, but their logical structure reveals something startling. If advanced civilizations can create simulations indistinguishable from reality, and if they choose to do so, then statistically speaking, we are far more likely to exist within one of those simulations than in the base reality. This reasoning stems from the sheer number of simulated beings that could theoretically outnumber biological ones by orders of magnitude. To grasp why this matters, consider the trajectory of human technological progress. Over the past century alone, humanity has transitioned from rudimentary mechanical devices to complex digital systems capable of rendering photorealistic graphics and simulating entire ecosystems. Virtual reality and artificial intelligence continue to blur the line between the physical and the virtual. If this trend continues, it's conceivable that future generations will possess the computational power to simulate not just environments, but entire universes populated with sentient beings. Now imagine scaling this up across countless civilizations throughout the cosmos. Each civilization that achieves this level of technological sophistication could generate trillions of simulated realities, each containing billions of simulated individuals. In such a scenario, the odds of being born into the original universe become astronomically small. Instead, we are far more likely to exist as characters in someone else's grand experiment, a digital construct unaware of its artificial origins. While the simulation hypothesis often feels like the stuff of Hollywood blockbusters, it draws upon legitimate scientific principles. Quantum mechanics, for instance, hints at the possibility of a simulated reality. Consider the peculiar behavior of particles at subatomic scales. Electrons appear to exist in multiple states simultaneously until observed, collapsing into a single outcome only when measured. This phenomenon aligns intriguingly with the mechanics of a video game, where objects are rendered only when needed to conserve processing power. Similarly, the holographic principle in theoretical physics posits that the information describing our three-dimensional universe could be encoded on a two-dimensional surface, much like a computer screen displaying a 3D environment. Advances in neuroscience also lend credence to the hypothesis. Our brains process sensory input in ways that resemble data streams fed into a simulation. Sight, sound, touch. All of these experiences are reconstructed internally based on electrical signals transmitted from our senses. Could it be that what we perceive as reality is simply the output of a highly advanced neural interface, tricking us into believing we're interacting with a tangible world? Even skeptics acknowledge that dismissing the simulation hypothesis outright requires addressing fundamental gaps in our understanding of consciousness and the cosmos. For instance, why does mathematics, a human invention, so perfectly describe the workings of the universe? Could this suggest that the universe operates according to rules deliberately programmed into its fabric? Or is it merely a coincidence, a product of natural laws emerging without intent? If the simulation hypothesis were proven true, its implications would ripple through nearly every aspect of human existence. First and foremost, it would force us to reconsider the meaning of life. Many philosophical traditions argue that life derives purpose from its inherent uniqueness, that we matter because we are finite, fragile, and irreplaceable. But in a simulated universe, this premise collapses. If infinite versions of ourselves exist across countless iterations of reality, then individuality loses its weight. Every triumph, failure, relationship, and decision becomes part of a preordained script, devoid of ultimate significance. Morality, too, would face upheaval. Ethical frameworks often rely on the assumption of free will, the belief that individuals have agency over their actions and are therefore accountable for them. However, in a simulation, free will might be an illusion. Just as characters in a video game follow predetermined paths dictated by their programming, so too might humans operate under constraints invisible to us. If our choices are scripted, does moral responsibility still apply? Can we hold ourselves or others accountable for actions that were never truly ours to begin with? Identity poses another challenge. Who, or what, are we if not biological entities inhabiting a physical universe? In a simulated reality, the self could be reduced to a collection of data points, a string of code representing memories, emotions, and personality traits. This raises uncomfortable questions about continuity and authenticity. If your consciousness were copied and uploaded into a new body, would that version of you still be you? And if dying in the simulation means erasure from the program, does death carry the same weight as it does in the real world? One of the most provocative aspects of the simulation hypothesis is whether knowledge of our simulated status would alter our experience of life. On one hand, discovering that we live in a simulation could liberate us from existential dread. After all, if nothing is real, then suffering, injustice, and mortality lose their sting. Life becomes a grand performance, a cosmic play staged for reasons unknown. Freed from the burden of ultimate meaning, we might embrace existence purely for its aesthetic value, savoring the fleeting beauty of each moment without attachment to outcomes. On the other hand, such knowledge could plunge us into despair. If everything is fabricated, then efforts to improve the world or pursue personal growth feel futile. Why strive for justice, love, or creativity when none of it has lasting impact? Moreover, the realization that our lives are controlled by an external programmer might breed resentment or nihilism. Are we merely pawns in someone else's game, destined to repeat cycles of joy and pain for their amusement? Or worse, indifference? Interestingly, some argue that ignorance truly is bliss. If we cannot prove or disprove the simulation hypothesis, perhaps it's better to live as though reality is authentic. Whether or not we're simulated, the emotions, relationships, and experiences we cherish remain meaningful to us. From this perspective, the truth matters less than how we choose to engage with the world. As we grapple with the unsettling possibilities raised by the simulation hypothesis, another philosophical conundrum emerges. How can we trust our perceptions at all? If the universe is a simulation, then everything we see, hear, and feel could be an elaborate fabrication. But even outside the context of simulations, doubts about the reliability of our senses have haunted thinkers for centuries. Enter René Descartes and his infamous thought experiment, Descartes' evil demon. Descartes imagined a malevolent entity, an evil demon, with the power to deceive him at every turn. This demon manipulates his senses, making him believe falsehoods about the external world. In this scenario, nothing is certain, not the solidity of objects, not the passage of time, not even the existence of his own body. The only thing Descartes could affirm with absolute certainty was his own act of doubting. Cogito ergo sum. I think, therefore I am. The parallels between Descartes' evil demon and the simulation hypothesis are striking. Both challenge the notion of objective reality, forcing us to question whether anything exists beyond our subjective experience. While the simulation hypothesis frames deception as a product of advanced technology, Descartes' demon introduces the possibility of metaphysical manipulation. Together, these ideas underscore the fragility of human perception and the limits of our ability to discern truth. So, as we leave behind the dizzying implications of the simulation hypothesis, let us turn our attention to Descartes' evil demon. Is there any way to know whether the world we perceive is genuine? Or are we forever trapped in a labyrinth of uncertainty, unable to distinguish reality from illusion? Descartes' evil demon, the fragility of perception and the search for certainty. Imagine a world where nothing is as it seems. Every sight, sound, and sensation you experience is fabricated, a deliberate deception orchestrated by a malevolent force intent on misleading you. René Descartes, one of history's most influential philosophers, conjured this unsettling scenario in his quest to uncover indubitable truth. He envisioned an evil demon, a supremely powerful being with the ability to manipulate his senses, feeding him false impressions of the external world. In this nightmarish thought experiment, Descartes questioned whether anything could be trusted, not the solidity of objects, not the passage of time, not even the existence of his own body. If your senses can deceive you, how do you know what's real? This radical skepticism serves as both a philosophical challenge and a profound meditation on the nature of knowledge. By doubting everything, Descartes sought to strip away all assumptions, leaving only that which could withstand the harshest scrutiny. What remains, he concluded, is the act of thinking itself, the undeniable proof that I think, therefore I am. Cogito ergo sum. Yet even this foundational belief leaves room for doubt about the external world. If we cannot trust our senses, how do we navigate a reality built on assumptions? And can we ever escape the illusions crafted by our minds? Or perhaps by an evil demon? To fully appreciate the implications of Descartes' thought experiment, we must delve into its origins, unpack its reasoning, and explore the existential questions it raises. Descartes introduced the concept of the evil demon in his seminal work, Meditations on First Philosophy, published in 1641. His goal was ambitious: to establish a firm foundation for knowledge by rejecting any belief that could be doubted. This methodical doubt led him to question the reliability of sensory perception, mathematical truths, and even the existence of the physical world. The evil demon serves as a metaphorical embodiment of doubt. Unlike mere errors or misperceptions, the demon represents a systematic, intentional effort to deceive. It distorts reality so completely that no observation or experience can be taken at face value. For instance, when you see a tree, how can you be sure it isn't a fabrication planted in your mind by the demon? When you feel heat from the sun, how do you know it isn't an illusion designed to trick you? Even abstract concepts like mathematics might be corrupted. Perhaps the demon has rewritten the rules of logic to lead you astray. Through this extreme form of skepticism, Descartes dismantles the edifice of human understanding, brick by brick. He rejects reliance on sensory evidence because the senses are prone to error, e.g., optical illusions, hallucinations. He questions empirical observations because they depend on those same fallible senses. He even entertains the possibility that God, a benevolent creator traditionally seen as the guarantor of truth, might instead be a deceiver. By systematically undermining every source of certainty, Descartes arrives at a state of hyperbolic doubt, when nothing seems beyond question. Yet amid this intellectual abyss, one truth emerges unscathed: the fact that he is thinking. To doubt requires a doubter, and to think requires a thinker. Thus, Descartes concludes that his very act of doubting proves his existence. "I think, therefore I am," becomes the cornerstone of his philosophy, a self-evident proposition immune to the demon's machinations. While the cogito provides a secure starting point, it also highlights the limitations of human knowledge. Descartes' insight affirms the existence of a thinking self, but it says nothing about the external world. The evil demon remains a lurking possibility, casting doubt over everything outside the mind. How, then, do we move beyond solipsism, the notion that only one's own mind is certain to exist, and rebuild a coherent picture of reality? Descartes attempts to resolve this dilemma by invoking God. He argues that since he has an innate idea of a perfect being, and since imperfection cannot conceive perfection, this idea must originate from a truly perfect source: God. Furthermore, a perfect God would not deceive, ensuring that clear and distinct perceptions correspond to objective reality. With this argument, Descartes seeks to restore confidence in sensory experience and rational inquiry. However, critics have long debated the validity of Descartes' reasoning. Some argue that his leap from the cogito to the existence of God is unwarranted, relying on circular logic. Others contend that even if God exists, the problem of perceptual error persists. After all, humans routinely misinterpret their surroundings despite divine providence. Moreover, the modern scientific worldview complicates matters further. Advances in neuroscience reveal that perception is not a direct window onto reality, but a constructed simulation generated by the brain. Our senses filter, interpret, and sometimes distort incoming data, creating a representation of the world that may bear little resemblance to its true nature. In light of these challenges, Descartes' evil demon takes on renewed relevance. While few today believe in literal demons manipulating our minds, the underlying principle, that perception is inherently unreliable, resonates deeply. Optical illusions, cognitive biases, and virtual reality technologies demonstrate how easily our brains can be misled. Even without supernatural intervention, the gap between appearance and reality looms large. If we cannot trust our senses, how do we navigate a world built on assumptions? Consider the practical implications of living in constant doubt. Everyday activities, from crossing the street to forming relationships, rely on implicit trust in the reliability of perception. Without this trust, life becomes paralyzed by uncertainty. How do you know the ground beneath your feet won't vanish? How do you know the person speaking to you isn't a figment of your imagination? Philosophically, the evil demon forces us to confront the fragility of human knowledge. Science, art, religion, all domains of human endeavor rest on shared beliefs about the external world. But if those beliefs are illusions, then the entire structure of civilization teeters on shaky ground. For example, scientific theories assume a consistent, observable universe governed by natural laws. Yet if the universe is a fabrication, those laws might be arbitrary constructs imposed by the demon. Similarly, moral systems presuppose a stable reality where actions have consequences. But in a simulated or manipulated world, morality loses its anchor, becoming a subjective construct devoid of universal validity. On a personal level, the evil demon raises existential questions about identity and meaning. Who are you if not the sum of your experiences and interactions? If those experiences are fabrications, does your sense of self dissolve into nothingness? And if life lacks objective purpose, why bother striving for anything at all? These dilemmas evoke a mix of despair and liberation. On one hand, the realization that reality might be an illusion can induce nihilism, a sense that nothing truly matters. On the other hand, it invites a playful curiosity about the nature of existence. Perhaps the search for truth is less about finding definitive answers and more about embracing the mystery. After all, even in a simulated or demon-haunted world, the richness of human experience remains undeniable. Love, beauty, creativity. These phenomena retain their power to inspire and transform, regardless of their ultimate origin. Given the pervasive influence of the evil demon, is there any way to escape its grasp? Descartes believed that appealing to God offered a path out of skepticism. By positing a benevolent deity who ensures the veracity of clear and distinct ideas, he hoped to bridge the chasm between mind and world. However, as noted earlier, this solution is far from universally accepted. Modern approaches to the problem often emphasize pragmatism. Rather than seeking absolute certainty, we accept that knowledge is provisional and context-dependent. Scientific methods, for instance, prioritize predictive accuracy over metaphysical truth. Even if our models of reality are incomplete or approximate, they enable us to interact effectively with the world. Likewise, social conventions and cultural narratives provide frameworks for collective understanding, allowing communities to function despite individual doubts. Another perspective comes from embracing ambiguity. Instead of viewing uncertainty as a threat, we can see it as an invitation to explore alternative modes of being. Meditation, mindfulness, and artistic expression offer ways to transcend the limitations of perception, tapping into dimensions of experience that defy rational analysis. By cultivating awareness of the present moment, we may glimpse glimpses of reality untouched by the demon's deceptions. Ultimately, the question of whether we can escape the illusion depends on how we define escape. If freedom means attaining absolute certainty, then perhaps escape is impossible. But if freedom means learning to live gracefully within uncertainty, if it means finding joy, connection, and meaning despite the unknown, then escape becomes not only possible, but inevitable. As we grapple with the implications of Descartes' evil demon, another dimension of reality comes under scrutiny: time. If perception is unreliable, how can we trust our experience of time's flow? Is time linear, progressing steadily from past to future? Or is it cyclical, repeating endlessly like the turning of seasons? Could it be something stranger still, perhaps a static four-dimensional block encompassing all moments simultaneously? Albert Einstein's theory of relativity offers a provocative answer. According to Einstein, time is not an independent entity flowing uniformly across the cosmos. Instead, it merges with space to form a unified fabric called spacetime. Within this framework, past, present, and future coexist as fixed coordinates, much like pages in a book waiting to be read. This concept, known as the block universe theory, challenges our intuitive understanding of temporality and raises profound questions about free will, causality, and the nature of existence. So, as we leave behind the haunting specter of the evil demon, let us turn our attention to the block universe. In doing so, we'll explore how time itself might be an illusion, one that reshapes our understanding of reality in ways both dazzling and disorienting. Einstein's block universe, a four-dimensional tapestry of time. Albert Einstein, one of the most revolutionary thinkers in human history, forever changed how we understand the cosmos, not only through his groundbreaking equations, but also through his profound insights into the nature of reality itself. Central to his theory of relativity is the notion that time is not an independent, flowing river carrying us inexorably from past to future. Instead, time merges with space to form a unified four-dimensional continuum known as space-time. Within this framework, every moment, past, present, and future, exists simultaneously, like pages in a book or frames in a movie reel. This concept, often referred to as the block universe model, challenges our intuitive understanding of temporality and raises profound questions about free will, determinism, and mortality. To grasp the implications of the block universe, imagine flipping open a novel. Each page represents a slice of time, already written and immutable. While you may read the story sequentially, experiencing events as they unfold, the entire narrative exists at once within the book's covers. In much the same way, Einstein's block universe suggests that all moments in time are equally real, existing all at once in a static, unchanging structure. Your birth, your current thoughts, and even your eventual death are fixed coordinates in this four-dimensional tapestry, woven together in a grand design beyond human comprehension. But what does it mean for us, as conscious beings navigating this eternal expanse? And how does this perspective alter our relationship with time and with ourselves? At its core, the block universe model arises from Einstein's theory of general relativity, which describes gravity not as a force, but as the curvature of space-time caused by mass and energy. According to this theory, time is not separate from space. Rather, it combines with three spatial dimensions, length, width, height, to create a four-dimensional manifold. Events within this manifold are located using four coordinates, 3 for space and 1 for time. Just as points in physical space can be plotted on a map, events in space-time can be pinpointed with precision. However, unlike the familiar three-dimensional world we inhabit, space-time introduces a counterintuitive twist. Time behaves differently depending on relative motion and gravitational fields. For example, two observers traveling at different speeds or experiencing varying levels of gravity will measure time differently, a phenomenon known as time dilation. These effects have been experimentally verified countless times, such as through atomic clocks aboard satellites used in GPS systems. Yet, despite these relativistic quirks, the overarching principle remains consistent. Time is not a dynamic process unfolding moment by moment, but a static dimension embedded in the fabric of the universe. The analogy of a movie reel helps clarify this idea. When watching a film, you perceive motion because individual frames flash before your eyes in rapid succession. However, if you were to pause the projector and examine the reel itself, you would see that all frames exist simultaneously, arranged in sequence along the strip. Similarly, in the block universe, every event, from the Big Bang to your last breath, occupies a specific location in space-time, forming a complete and unchanging record of existence. This view stands in stark contrast to our everyday experience of time. We feel it slipping away, moment by moment, as though carried forward by some invisible current. But according to Einstein, this sensation is an illusion created by our limited perspective. From a cosmic vantage point, there is no flow of time. Instead, the entirety of history stretches out before us, frozen and eternal. If time is indeed static and all moments coexist, then profound philosophical implications arise. One of the most pressing concerns is the question of free will. If every decision, action, and consequence already exists as part of the block, then do we truly have agency over our lives? Or are we merely actors following a predetermined script, powerless to deviate from the roles assigned to us? Consider the act of making a choice. Imagine standing at a crossroads, deliberating between two paths. You weigh the pros and cons, consult your instincts, and finally decide which way to go. From a subjective standpoint, this decision feels meaningful. It reflects your desires, values, and autonomy. But in the block universe, both outcomes already exist as fixed points in spacetime. One path leads to success, the other ends in failure. Both versions of you traverse their respective timelines, unaware of the other's existence. In this light, the very concept of choice becomes ambiguous. Did you genuinely choose, or did the universe simply play out its preordained course? This tension between determinism and free will has long haunted philosophers and scientists alike. On one hand, the block universe seems to support a deterministic worldview where every event is causally linked to those preceding it. Every particle's trajectory, every neural firing, every heartbeat follows inexorably from prior conditions. There is no room for randomness or spontaneity. Everything unfolds according to the laws of physics. On the other hand, human consciousness resists this reductionist interpretation. Our sense of selfhood, creativity, and moral responsibility hinges on the belief that we possess the capacity to shape our destinies. One possible resolution lies in redefining free will. Rather than viewing it as the ability to alter the course of events, perhaps free will resides in the subjective experience of choosing. Even if all outcomes are predetermined, the act of deliberation and decision-making imbues life with meaning. From this perspective, free will isn't about changing the future, but about engaging authentically with the present. Another implication of the block universe pertains to our understanding of mortality. Death looms large in human consciousness, casting a shadow over our brief sojourn in time. Yet in the block universe, death loses some of its finality. If every moment of your life exists eternally within space-time, then in a sense, you are always alive, simply occupying different slices of the continuum. Your laughter at age 5, your struggles as a teenager, and your reflections as an elder all persist side by side, untouched by decay or dissolution. While this realization may offer comfort to some, it also raises unsettling questions. If nothing truly ends, does anything truly matter? Without the urgency of fleeting time, how do we find purpose and motivation? Despite its elegance, the block universe challenges deeply ingrained intuitions about the nature of existence. To reconcile this abstract concept with lived experience, we must grapple with a tension between objective reality and subjective perception. Objectively, time is static. Subjectively, it flows. How do we bridge this divide? One approach involves recognizing the role of memory and anticipation in shaping our temporal awareness. Memories allow us to reconstruct the past, while expectations enable us to envision the future. Together, these cognitive processes create the illusion of movement through time. Though the block universe suggests that all moments are equally real, our brains filter and organize information in ways that emphasize continuity and change. This selective attention gives rise to the sensation of living in the now, even as the broader structure of space-time remains unchanged. Another avenue for exploration lies in embracing the paradoxes inherent in the block universe. Perhaps the coexistence of determinism and free will, eternity, and impermanence reflects the dual nature of reality itself. Just as quantum mechanics reveals particles behaving both as waves and discrete entities, so too might time exhibit complementary aspects, static yet dynamic, eternal yet ephemeral. By holding these contradictions in balance, we gain a richer, more nuanced appreciation for the complexities of existence. Ultimately, the block universe invites us to transcend conventional notions of time and embrace a broader perspective. While it may unsettle our assumptions, it also opens new avenues for wonder and contemplation. Freed from the constraints of linear temporality, we can marvel at the intricate interplay of cause and effect, the interconnectedness of all moments, and the timeless beauty of the cosmos. As we reflect on the eternal nature of time in the block universe, another intriguing question emerges. What about the matter that composes us? Are the atoms in our bodies transient visitors, passing briefly through our existence before moving on to new forms? Or do they endure across eons, linking us to ancient stars and distant galaxies? This line of inquiry leads us directly to the cosmic recycling theory, which posits that the elements making up our physical selves originated in the hearts of dying stars billions of years ago. Through stellar nucleosynthesis, these atoms were forged, scattered across space, and eventually incorporated into planets, organisms, and ultimately, you. Consider the iron in your blood, the calcium in your bones, the carbon in your DNA. All of these elements began their journeys in the fiery crucibles of supernovae. When massive stars exhaust their nuclear fuel, they collapse under their own gravity, releasing tremendous energy and ejecting heavy elements into the surrounding cosmos. Over billions of years, these materials coalesce to form new stars, planets, and life forms. In this sense, we are quite literally stardust, connected to the vast cycles of creation and destruction that define the universe. So, as we leave behind the static immensity of the block universe, let us turn our gaze inward, to the atoms coursing through our veins. By exploring the cosmic recycling theory, we'll uncover the poetic symmetry of existence, where the infinite expanse of space-time meets the intimate dance of matter and energy. Together, these perspectives remind us that while time may be eternal, the stuff of life is endlessly recycled, binding us to the cosmos in ways both profound and mysterious. The cosmic recycling theory, stardust, and the symphony of existence. Every atom in your body has a story older than humanity itself. These atoms were born in the fiery hearts of ancient stars, forged under unimaginable pressures and temperatures before being scattered across the cosmos. They journeyed through the vastness of space, riding waves of stellar winds and cataclysmic explosions until they eventually found their way into you. To say that we are made of stardust is not poetic hyperbole. It is a scientific fact, grounded in the processes of stellar nucleosynthesis and the cycles of cosmic creation and destruction. But what does it mean to be composed of recycled star matter? Does this realization connect us to something larger, or does it diminish our sense of individuality? And if even stars, the titans of the universe, are temporary, what does permanence truly mean? The cosmic recycling theory invites us to reflect on these profound questions, weaving together astrophysics, philosophy, and existential inquiry. By understanding how elements are created, dispersed, and reincorporated into new forms, we gain insight into the interconnectedness of all things. This theory reveals that life, as we know it, is part of an eternal dance, a grand recycling process that spans billions of years and countless generations of stars. As we delve deeper into this concept, we will explore its origins, implications, and the ways it reshapes our understanding of existence. At the heart of the cosmic recycling theory lies the process of stellar nucleosynthesis, the mechanism by which stars create the chemical elements essential for life. To comprehend this phenomenon, we must first appreciate the extraordinary conditions within stars. Born from clouds of gas and dust, stars ignite when nuclear fusion begins in their cores, fusing hydrogen atoms into helium and releasing vast amounts of energy in the form of light and heat. Over millions or even billions of years, stars continue to fuse lighter elements into heavier ones, progressing through stages of carbon, oxygen, silicon, and beyond. This alchemical transformation reaches its crescendo in the final moments of a star's life. When a massive star exhausts its nuclear fuel, it can no longer resist the inward pull of gravity. The core collapses violently, triggering a supernova explosion so powerful that it briefly outshines entire galaxies. In this cataclysmic event, the intense heat and pressure enable the formation of elements heavier than iron, gold, silver, uranium, and others, which would otherwise be impossible to produce. These newly minted elements are ejected into space, enriching the interstellar medium with the raw materials needed to form new stars, planets, and life. The remnants of these stellar deaths become the seeds of future creation. Gas and dust enriched with heavy elements coalesce over eons, forming protostars and planetary systems. On some of these planets, under the right conditions, complex chemistry gives rise to organic molecules, setting the stage for the emergence of life. In this way, the universe recycles its building blocks endlessly, ensuring that the death of one generation of stars paves the way for the birth of another. Our solar system, including Earth, owes its existence to this cosmic cycle. The carbon in your DNA, the calcium in your bones, and the iron in your blood were all forged in the crucibles of long-dead stars. Every breath you take contains nitrogen and oxygen, elements synthesized in stellar interiors. Even the water you drink consists of hydrogen formed shortly after the Big Bang and oxygen created in the hearts of stars. Thus, we carry within us the legacy of countless stellar lives, each contributing to the intricate tapestry of existence. The realization that we are literally made of stardust carries profound philosophical implications. It challenges us to reconsider our place in the universe and the nature of our identity. If the atoms in our bodies have existed for billions of years, traversing unimaginable distances and participating in the formation of galaxies, stars, and planets, then what does it mean to be human? Are we merely temporary configurations of recycled matter destined to dissolve back into the cosmic reservoir? Or does our consciousness imbue these atoms with unique significance, transforming inert particles into vessels of thought, emotion, and creativity? One perspective is that recognizing our stellar origins connects us to something far greater than ourselves. We are not isolated beings adrift in an indifferent cosmos. Rather, we are threads woven into the fabric of a vast, interconnected web. The same elements that compose us also constitute mountains, oceans, and distant nebulae. This shared ancestry fosters a sense of kinship with the universe, reminding us that we are participants in a grand, ongoing story, one that transcends the boundaries of time and space. At the same time, acknowledging our cosmic origins can evoke feelings of insignificance. If the atoms in our bodies have existed for billions of years, and will persist long after we are gone, then what makes our brief appearance special? From this vantage point, human life seems fleeting and inconsequential, a mere blip in the endless cycle of creation and destruction. Yet, paradoxically, this recognition can also inspire awe. The fact that conscious beings capable of contemplating their own existence arose from the ashes of dead stars is nothing short of miraculous. Our ability to think, dream, and wonder elevates us, however briefly, above the mechanistic processes that govern the universe. Another implication of the cosmic recycling theory is its commentary on impermanence. Stars, those luminous giants that dominate the night sky, are not eternal. Their brilliance fades, their cores collapse, and their remnants scatter across the void. Planets, too, are subject to decay, whether through natural processes or catastrophic events like asteroid impacts or supernovae. Even black holes, the most enduring relics of stellar evolution, will eventually evaporate through Hawking radiation. Everything in the universe is temporary, even the very elements that compose us. This pervasive impermanence raises questions about the nature of permanence itself. If nothing lasts forever, then what gives life meaning? One answer lies in embracing change as a fundamental aspect of existence. Just as stars transform themselves into new elements, so too do humans evolve, adapt, and contribute to the collective legacy of the cosmos. Our impact may be fleeting, but it ripples outward, influencing future generations and leaving traces of our presence in the universe. In this sense, permanence is not about duration, but about contribution, about adding something meaningful to the eternal symphony of creation. The cosmic recycling theory bridges the gap between science and spirituality, offering a framework for understanding our place in the cosmos without resorting to dogma or mysticism. For millennia, humans have sought answers to existential questions through mythologies, religions, and philosophies. Many traditions emphasize the interconnectedness of all things, often using metaphors of cycles, rebirth, and unity. The cosmic recycling theory provides a scientific basis for these intuitions, revealing that the universe operates according to principles of renewal and transformation. Consider the concept of karma, central to Hinduism and Buddhism, which posits that actions have consequences that reverberate across lifetimes. While traditionally interpreted in moral terms, karma can also be seen as a metaphor for the physical laws governing the universe. Every action, a supernova explosion, a collision of galaxies, the formation of a planet, has repercussions that shape the course of cosmic history. Similarly, the idea of reincarnation aligns with the notion that matter is endlessly recycled, taking on new forms while retaining its essence. Modern environmental ethics also finds resonance in the cosmic recycling theory. Recognizing that we are part of a larger ecological system encourages stewardship of the Earth and its resources. Just as the universe recycles its building blocks, so too must we adopt sustainable practices that honor the interconnectedness of all life. By viewing ourselves as custodians of the cosmos, we assume responsibility for preserving the delicate balance that sustains us. Ultimately, the cosmic recycling theory invites us to adopt a universal perspective, one that transcends narrow definitions of selfhood and embraces the broader context of existence. Whether framed in scientific, spiritual, or ethical terms, this theory underscores the beauty and complexity of the universe, reminding us that we are both products and participants in its ceaseless evolution. As we marvel at the cosmic processes that gave rise to life on Earth, one question inevitably arises. Where is everyone else? If the universe is teeming with potential life, if countless planets orbit stars scattered throughout the galaxy, why haven't we detected any signs of extraterrestrial civilizations? This enigma, known as the Fermi Paradox, poses one of the most tantalizing mysteries in modern science. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" During a casual lunch conversation, the paradox highlights a striking contradiction. On one hand, the sheer scale of the universe suggests that intelligent life should be abundant. With billions of galaxies, each containing billions of stars and potentially habitable planets, the odds of Earth being the sole cradle of life seem astronomically low. On the other hand, despite decades of searching, we have yet to find definitive evidence of alien civilizations. Several explanations have been proposed to resolve this paradox. Some suggest that advanced civilizations may destroy themselves before reaching out, succumbing to nuclear war, environmental collapse, or other existential threats. Others propose that aliens might choose to remain silent, either to avoid detection or because communication across vast interstellar distances is impractical. Still, others speculate that extraterrestrial intelligence exists, but operates on scales or dimensions beyond our comprehension, rendering it invisible to current technology. Regardless of the explanation, the Fermi Paradox forces us to confront humbling possibilities. Perhaps life is exceedingly rare, requiring conditions so specific that Earth represents a cosmic anomaly. Or perhaps we are simply too primitive to recognize the signals emanating from advanced civilizations. Either way, the silence of the cosmos deepens the mystery of our origins and underscores the urgency of exploring the universe further. So, as we leave behind the poetic symmetry of the cosmic recycling theory, let us turn our attention to the Fermi Paradox. By grappling with the absence of evidence for extraterrestrial life, we confront not only the vastness of the cosmos, but also the fragility and uniqueness of our own existence. Together, these perspectives remind us that while we are children of the stars, we remain explorers of an uncharted frontier, searching for answers to humanity's most profound questions. The Fermi Paradox. Echoes in an empty cosmos. Enrico Fermi, the brilliant physicist whose work shaped much of modern science, once posed a question so simple yet profound that it continues to haunt humanity's collective imagination. Where is everybody? Fermi's query emerged during a casual lunch conversation in 1950, but its implications ripple far beyond idle speculation. Given the sheer scale of the universe, shouldn't intelligent civilizations be everywhere? With billions of galaxies, each containing billions of stars and planets, the statistical likelihood of life existing elsewhere seems overwhelming. Yet despite decades of searching, through radio telescopes, space probes, and mathematical models, we have found no definitive evidence of extraterrestrial intelligence. This glaring contradiction forms the heart of the Fermi Paradox, a mystery that challenges not only our scientific understanding, but also our deepest existential questions about loneliness, significance, and the nature of consciousness itself. The paradox forces us to confront uncomfortable possibilities. Are we truly alone in the cosmos? A statistical anomaly in an otherwise indifferent universe? Or are advanced civilizations hiding, observing us silently from the shadows? Could they communicate in ways so alien that we fail to recognize their signals? Alternatively, might the silence stem from self-destruction, with civilizations extinguishing themselves before reaching out? Each of these scenarios carries profound implications, reshaping how we view ourselves and our place in the grand cosmic narrative. As we delve into the Fermi Paradox, we will explore its origins, examine potential explanations, and reflect on what it reveals about human nature and the universe at large. To grasp the magnitude of the Fermi Paradox, consider the staggering numbers involved. Our observable universe contains approximately 2 trillion galaxies, each home to hundreds of billions of stars. Many of these stars harbor planets within their habitable zones, regions where conditions might allow liquid water, a key ingredient for life as we know it. Estimates suggest there could be tens of billions of Earth-like planets in our galaxy alone. Even if only a tiny fraction of these planets develop life, and an even smaller fraction evolve intelligent civilizations, the odds seem overwhelmingly in favor of extraterrestrial existence. Yet, despite this abundance of potential, evidence remains elusive. Since the mid-20th century, scientists have employed various methods to detect signs of alien life. Projects like SETI, Search for Extraterrestrial Intelligence, scan the skies for artificial radio signals or other technosignatures indicative of advanced civilizations. Space missions probe nearby planets and moons for microbial life, while theoretical frameworks attempt to predict the behaviors and motivations of hypothetical extraterrestrials. Despite these efforts, the cosmos remains eerily silent. This absence of evidence creates a paradox. On one hand, the vastness of the universe suggests that intelligent life should be common. On the other hand, our inability to find it contradicts this expectation. To resolve this tension, researchers have proposed numerous hypotheses, ranging from practical limitations in our search methods to more speculative ideas about the nature of extraterrestrial intelligence. However, none provide a fully satisfactory explanation, leaving the Fermi Paradox as one of the most enduring mysteries in astrophysics. Several theories attempt to account for the apparent absence of extraterrestrial civilizations. One possibility is that advanced societies destroy themselves before achieving interstellar communication. History offers ample examples of civilizations collapsing due to environmental degradation, resource depletion, or internal conflict. If technological progress inevitably leads to existential risks, such as nuclear war, artificial intelligence gone rogue, or runaway climate change, it's conceivable that many civilizations perish before they can reach out to others. In this scenario, humanity itself may face a similar fate unless we learn to navigate the perils of technological advancement. Another explanation posits that extraterrestrial civilizations exist but choose to remain hidden. Known as the zoo hypothesis, this idea suggests that advanced beings deliberately avoid contact with less developed species, akin to zookeepers preserving wildlife habitats without interference. From this perspective, Earth might be part of a cosmic preserve, observed but untouched by higher intelligences. While intriguing, this theory raises ethical questions about paternalism and the rights of developing civilizations. Moreover, it assumes a level of coordination among disparate alien societies, an assumption that strains credulity given the immense distances separating them. A third possibility is that extraterrestrial signals exist but elude detection because they operate on scales or frequencies beyond our comprehension. For instance, aliens might communicate using neutrinos, gravitational waves, or quantum entanglement, methods undetectable with current technology. Alternatively, their messages could encode information in ways so complex that we mistake them for natural phenomena. This explanation highlights the limitations of human perception and underscores the need for humility when interpreting data from the cosmos. Finally, some argue that life itself may be exceedingly rare, requiring conditions so specific that Earth represents a cosmic fluke. While the building blocks of life, organic molecules, water, and energy, are abundant throughout the universe, the precise combination needed for biology to emerge might occur infrequently. If true, this would imply that humanity occupies a unique position in the cosmos, a notion both humbling and isolating. The Fermi Paradox evokes a profound sense of existential unease. At its core lies the tension between two competing emotions: awe at the universe's vastness and dread at its apparent emptiness. On one hand, the realization that we inhabit a galaxy teeming with planets inspires wonder and curiosity. It reminds us of the infinite possibilities inherent in creation, fueling dreams of exploration and discovery. On the other hand, the silence of the cosmos can feel suffocating, amplifying feelings of isolation and insignificance. Consider the psychological impact of believing we are alone. For millennia, humans have sought connection, not just with one another, but with something greater than ourselves. Religion, art, and philosophy often reflect this yearning for transcendence. Whether through communion with deities, immersion in beauty, or pursuit of knowledge. Discovering extraterrestrial life would validate this longing, affirming that consciousness extends beyond Earth's boundaries. Conversely, the absence of such evidence leaves us adrift, questioning whether our existence holds any meaning in a desolate universe. Yet the Fermi Paradox also invites introspection. If we are indeed alone, or at least unable to detect others, then the responsibility for shaping the future rests squarely on our shoulders. Humanity becomes the custodian of consciousness, tasked with ensuring its survival and flourishing. This burden carries both weight and purpose, reminding us of the fragility and preciousness of life. Whether or not we ever encounter extraterrestrials, the quest for answers compels us to better understand ourselves and our relationship with the cosmos. The Fermi Paradox transcends the realm of science, intersecting with philosophy, ethics, and metaphysics. It prompts us to reconsider fundamental questions about the nature of life, intelligence, and the universe itself. For instance, what defines intelligence? Must it mirror human cognition, or could it manifest in radically different forms? If alien minds operate according to principles entirely foreign to us, how would we recognize or even interact with them? Ethical considerations also arise. Should we actively seek contact with extraterrestrial civilizations, risking unintended consequences? Or should we adopt a precautionary approach, prioritizing passive observation over active engagement? These dilemmas echo debates surrounding first contact scenarios in science fiction, where encounters with alien life often serve as allegories for colonialism, xenophobia, and cooperation. Moreover, the Fermi Paradox challenges traditional notions of significance. If life is rare, does that elevate its value? Or does rarity render it meaningless, a fleeting anomaly in an otherwise indifferent cosmos? Conversely, if life is abundant yet silent, does that diminish its uniqueness or highlight the complexity of communication across vast distances? By grappling with these ambiguities, we deepen our appreciation for the intricacies of existence. As we contemplate the Fermi Paradox, another unsettling possibility emerges. Perhaps consciousness isn't tied to biology at all. In the vast expanse of space-time, random fluctuations could give rise to fleeting moments of awareness, entities known as Boltzmann Brains. Named after physicist Ludwig Boltzmann, who studied entropy and probability, these hypothetical constructs represent self-aware entities spontaneously emerging from chaos. Imagine a disembodied mind, complete with memories and perceptions, materializing briefly amidst the void. Unlike biological organisms, Boltzmann brains require no evolutionary history or environmental support. They arise purely through chance alignments of particles. Though ephemeral, these entities experience reality indistinguishably from sentient beings like ourselves. In fact, some interpretations of quantum mechanics and cosmology suggest that Boltzmann brains are statistically more likely than entire universes filled with conscious life. This concept deepens the mystery of the Fermi Paradox. If consciousness can emerge randomly, then what distinguishes real experiences from illusions generated by statistical anomalies? Are we Boltzmann brains ourselves, deluded into believing in a coherent timeline and external world? Or do we occupy a privileged position grounded in the physical substrate of Earth and its ecosystems? So as we leave behind the haunting silence of the cosmos, let us turn our attention to Boltzmann brains. By exploring this bizarre yet fascinating hypothesis, we confront the limits of our understanding and the fragile line between order and chaos. Together, these perspectives remind us that while the universe may be vast and enigmatic, the spark of awareness, whether rooted in biology or randomness, is a marvel worthy of contemplation. Boltzmann brains, fleeting sparks in the cosmic void. What if your mind, your thoughts, memories, and sense of self is not the product of billions of years of evolution, but rather a spontaneous fluctuation in space-time? Imagine waking up as a fully formed consciousness, complete with the illusion of a past, only to dissolve back into chaos moments later. This unsettling concept is embodied in the idea of a Boltzmann brain, a hypothetical self-aware entity that arises randomly due to quantum fluctuations in the fabric of the universe. Named after physicist Ludwig Boltzmann, who studied entropy and statistical mechanics, this thought experiment challenges our understanding of reality, perception, and existence itself. At its core, the Boltzmann brain hypothesis suggests that highly ordered structures, like brains capable of thought and self-awareness, can emerge temporarily from the chaotic randomness of the cosmos. These entities would perceive reality just long enough to ask questions like, "Why am I here?" or "What is real?" before fading away. While the notion seems absurd on the surface, it gains traction when considered within the framework of certain cosmological theories, particularly those involving infinite time and probabilistic fluctuations. If true, it raises profound questions about the reliability of our perceptions, the nature of consciousness, and whether we are living in a coherent, continuous universe, or merely fleeting illusions conjured by chance. To fully appreciate the implications of Boltzmann brains, we must delve into their origins, examine the science behind them, and grapple with the existential dilemmas they pose. As we explore this bizarre yet fascinating concept, we will confront the boundaries of human knowledge and the fragility of our assumptions about reality. The concept of Boltzmann brains originates from thermodynamics and statistical mechanics, fields pioneered by Austrian physicist Ludwig Boltzmann in the late 19th century. Boltzmann's work focused on entropy, a measure of disorder, and how systems tend to evolve towards states of higher entropy over time. For example, a deck of cards shuffled repeatedly becomes increasingly disordered, while an ice cube melts into water because liquid is more entropic than solid. However, Boltzmann also recognized that even highly disordered systems occasionally fluctuate into temporary states of order through random chance. In an infinite universe governed by probabilistic laws, such fluctuations become inevitable. Over vast timescales, particles might spontaneously arrange themselves into complex configurations, including arrangements resembling conscious beings. These ephemeral entities, dubbed Boltzmann brains in modern discussions, exist purely as statistical anomalies, fleeting sparks of awareness amid the void. To understand how this could happen, consider the sheer scale of possibility in an infinite universe. With enough time and space, every conceivable combination of matter and energy will eventually occur, no matter how improbable. A brain-like structure, complete with neural connections and subjective experiences, might arise spontaneously from quantum fluctuations, the same kind of fluctuations responsible for phenomena like virtual particles popping in and out of existence in empty space. Such a brain would lack any evolutionary history or biological context. It would simply appear, function briefly, and then vanish. Critically, Boltzmann brains challenge conventional notions of causality and continuity. Unlike biological organisms, which develop gradually through natural processes, these entities materialize fully formed, equipped with fabricated memories and perceptions. They experience reality as vividly as any human, yet their existence is entirely detached from the physical world. To a Boltzmann brain, the universe appears meaningful and coherent, but only because its perceptions are illusions generated by random chance. This idea intersects with broader debates in physics and philosophy about the nature of reality. Some interpretations of quantum mechanics suggest that observers play a fundamental role in shaping the universe. If Boltzmann brains are statistically more likely than entire universes filled with conscious beings, does that imply most observers are disembodied fluctuations rather than evolved life forms? And if so, what does that mean for our own status as observers? The existence of Boltzmann brains introduces a chilling paradox. If they are more probable than humans, how can we trust our perceptions of the world? After all, if most conscious entities are fleeting anomalies in a chaotic cosmos, then the odds favor us being Boltzmann brains ourselves. Every memory, sensation, and belief we hold dear could be nothing more than a fabrication, a momentary glitch in the fabric of space-time. Consider the implications for scientific inquiry. Much of what we know about the universe relies on empirical observation and logical reasoning. But if our minds are unreliable constructs born of randomness, then our conclusions about reality may be equally suspect. The laws of physics, the history of Earth, even the existence of other people, all could be illusions crafted by a Boltzmann brain's fleeting awareness. In this scenario, the quest for knowledge becomes a futile exercise, akin to chasing shadows in an ever-shifting dream. Yet the paradox deepens when we apply probabilistic reasoning to the multiverse hypothesis. Many cosmologists propose that our observable universe is just one among countless others, each with different initial conditions and physical constants. In such a multiverse, regions dominated by high entropy, chaos, vastly outnumber those with low entropy, order. Consequently, Boltzmann brains arising spontaneously in chaotic regions would far outnumber biological life forms evolving in orderly ones. By this logic, the majority of conscious experiences across the multiverse belong to Boltzmann brains, not humans. This conclusion undermines the Anthropic Principle, which posits that the universe appears fine-tuned for life because observers like us require specific conditions to exist. If Boltzmann brains dominate, then the apparent fine-tuning of the universe reflects not a deliberate design, but a statistical artifact. Most observers arise in chaotic environments where conditions resemble those conducive to consciousness. Thus, the very foundation of cosmology, the assumption that our observations reflect an objective reality, comes under scrutiny. Philosophically, the Boltzmann brain hypothesis forces us to confront the limits of human cognition. Our brains evolved to navigate a finite, predictable environment, not an infinite probabilistic cosmos. When faced with concepts like Boltzmann brains, we strain against the boundaries of intuition, struggling to reconcile the counterintuitive with the familiar. Are we Boltzmann brains, deluded into believing in a coherent timeline and external world? Or do we occupy a privileged position grounded in the physical substrate of Earth and its ecosystems? The answer remains elusive, leaving us suspended between skepticism and faith. The Boltzmann brain hypothesis bridges science and philosophy, challenging both disciplines to rethink their foundational assumptions. Scientifically, it highlights the tension between deterministic models of the universe and probabilistic interpretations of quantum mechanics. Philosophically, it underscores the fragility of certainty, reminding us that even our most cherished beliefs about reality rest on tenuous foundations. One way to approach this dilemma is through Occam's razor, the principle that favors simpler explanations over more complex ones. From this perspective, the existence of biological life forms supported by a stable, orderly universe seems more plausible than a proliferation of random fluctuations giving rise to countless Boltzmann brains. However, simplicity alone cannot resolve the paradox. Additional evidence or theoretical breakthroughs are needed to tip the scales. Another avenue involves redefining the nature of consciousness. If Boltzmann brains represent isolated instances of awareness, perhaps consciousness extends beyond individual entities, encompassing the universe as a whole. This panpsychist view posits that all matter possesses some degree of sentience, with complex structures like brains amplifying and organizing these qualities into what we recognize as subjective experience. While speculative, this framework offers a potential escape from the solipsism implied by Boltzmann brains, suggesting that consciousness is not a rare anomaly, but an intrinsic property of reality. Ultimately, the Boltzmann brain hypothesis invites humility. It reminds us that despite centuries of scientific progress, much about the universe remains mysterious and unknowable. Rather than despairing at this uncertainty, we can embrace it as a source of wonder and inspiration. Whether or not we are Boltzmann brains, the act of questioning our place in the cosmos connects us to something larger than ourselves, a shared journey of exploration and discovery. As we grapple with the unsettling implications of Boltzmann brains, another profound question emerges. Why does the universe seem perfectly fine-tuned for life? If Boltzmann brains dominate the multiverse, why do we find ourselves in a region where conditions support biological evolution? This puzzle leads directly to the Anthropic Principle, a cornerstone of modern cosmology that seeks to explain why the universe appears designed specifically for conscious observers. The Anthropic Principle comes in two forms, weak and strong. The weak version asserts that the universe must allow for observers, since we're here to observe it. Without the right conditions, such as precise values for physical constants like gravity and electromagnetism, life as we know it would be impossible. The strong version goes further, suggesting that the presence of observers somehow influences the structure of the universe, creating a feedback loop between consciousness and reality. Both versions raise intriguing possibilities. Could the fine-tuning of the universe reflect a deeper truth about the relationship between mind and matter? Or does it merely highlight the limitations of our current understanding? As we explore the Anthropic Principle, we will delve into the interplay between physics, metaphysics, and the search for meaning in an infinitely complex cosmos. So, as we leave behind the fleeting sparks of Boltzmann brains, let us turn our attention to the grand design of the universe. By examining why the cosmos seems tailored for life, we confront not only the mysteries of creation, but also the profound interconnectedness of all things. Together, these perspectives remind us that while existence may be fragile and fleeting, the spark of awareness, whether rooted in biology or randomness, is a marvel worthy of contemplation. The Anthropic Principle, a universe fine-tuned for life. Why does the universe appear so perfectly calibrated to support human existence? From the precise values of physical constants to the delicate balance of conditions required for life, the odds seem impossibly slim. Consider, for instance, the gravitational constant, a fundamental parameter that governs the strength of gravity. If this constant were even slightly different, stars would fail to form, galaxies would collapse, and planets like Earth would never exist. Similarly, the cosmological constant, which dictates the rate of expansion of the universe, must fall within an extraordinarily narrow range to allow for the emergence of complex structures. These examples are just the tip of the iceberg. Countless other factors, such as the ratio of matter to antimatter, the stability of atomic nuclei, and the properties of carbon, all align with astonishing precision to create a cosmos hospitable to life. This apparent fine-tuning has led many to wonder whether the universe is designed specifically for us. Is it evidence of divine intervention, suggesting a creator who crafted the cosmos with sentient beings in mind? Or could there be a more natural explanation rooted in probability and selection bias? These questions lie at the heart of the Anthropic Principle, a concept that seeks to address why the universe seems so exquisitely suited for conscious observers. At its core, the principle asserts that the universe must allow for observers since we're here to observe it. In other words, if the universe weren't compatible with life, we wouldn't exist to ponder its mysteries. While seemingly straightforward, this idea carries profound implications, forcing us to confront our place in the grand scheme of existence. To fully appreciate the significance of the Anthropic Principle, we must delve into its origins, examine its two primary interpretations, the weak and strong versions, and explore the philosophical and scientific ramifications of each. As we navigate this intricate landscape, we will confront questions about design, chance, and the nature of reality itself. The Anthropic Principle exists in two primary forms: the weak Anthropic Principle and the strong Anthropic Principle. Each offers a distinct lens through which to interpret the apparent fine-tuning of the universe. The weak Anthropic Principle is the more modest of the two. It states that the observed values of physical constants and initial conditions in the universe are constrained by the requirement that they permit the existence of observers. Put simply, we find ourselves in a universe capable of supporting life because, well, otherwise, we wouldn't be here to notice. This version of the principle is often framed as a form of selection bias. Just as fish don't question why their environment contains water, it's a prerequisite for their survival. Humans shouldn't be surprised to find themselves in a universe tailored for life. Weak Anthropic Principle doesn't attempt to explain why the universe is fine-tuned. It merely acknowledges the obvious fact that we can only observe universes compatible with our existence. In contrast, the strong Anthropic Principle makes a bolder claim. It posits that the laws of physics and the structure of the universe are somehow influenced or determined by the presence of conscious observers. According to this interpretation, the universe isn't just accidentally fine-tuned for life. It is fundamentally designed to produce consciousness. Some proponents of the strong Anthropic Principle argue that the act of observation plays a crucial role in shaping reality, echoing ideas from quantum mechanics such as the Copenhagen interpretation, where the collapse of wave functions depends on measurement. Others take the strong Anthropic Principle further, suggesting that the universe exists precisely because it must eventually give rise to sentient beings capable of perceiving it. Both versions of the Anthropic Principle have sparked intense debate among scientists, philosophers, and theologians. The weak Anthropic Principle is generally regarded as uncontroversial, serving as a useful reminder of the limitations inherent in anthropocentric reasoning. However, the strong Anthropic Principle ventures into more speculative territory. raising questions about causality, purpose, and the relationship between mind and matter. While some see it as a profound insight into the interconnectedness of all things, others dismiss it as metaphysical speculation lacking empirical support. The Anthropic Principle forces us to grapple with one of the most enduring questions in human history. Is the universe evidence of divine design, or can its apparent fine-tuning be explained through natural processes? Both perspectives offer compelling arguments, though neither provides definitive answers. For those inclined toward theology, the fine-tuning of the universe appears to point unmistakably toward intelligent design. The sheer improbability of so many variables aligning perfectly suggests deliberate intent, implying the existence of a creator who fashioned the cosmos with sentient beings in mind. This argument, often referred to as the teleological argument or the argument from design, resonates deeply with religious traditions across cultures. It invites us to view humanity not as an accident, but as the culmination of a cosmic plan, imbuing our existence with purpose and meaning. However, skeptics counter that invoking divine intervention risks falling into the trap of the God of the gaps, attributing unexplained phenomena to supernatural causes rather than seeking natural explanations. Instead, they propose alternative frameworks, such as the multiverse hypothesis, which posits the existence of countless parallel universes, each with different physical laws and constants. In this scenario, the vast majority of these universes would be inhospitable to life, but a small fraction would possess the right conditions to support conscious observers. Since we necessarily inhabit one of these rare, life-friendly universes, the apparent fine-tuning becomes a matter of statistical inevitability rather than divine design. This multiverse interpretation aligns closely with the weak Anthropic Principle, framing the fine-tuning problem as a form of selection bias. Just as lottery winners don't question why they were chosen, they recognize that someone had to win. We shouldn't be surprised to find ourselves in a universe capable of supporting life. While elegant in its simplicity, this explanation raises additional questions. For example, how do we test the multiverse hypothesis given that other universes, by definition, lie beyond our observational reach? And if infinite universes exist, what does that mean for concepts like probability and uniqueness? Philosophically, the Anthropic Principle also challenges traditional notions of significance. If the universe is fine-tuned for life, does that elevate humanity's importance, positioning us as central players in the cosmic drama? Or does it diminish our status, reducing us to mere byproducts of random fluctuations in an indifferent multiverse? These tensions highlight the dual nature of the Anthropic Principle. It can inspire awe and humility simultaneously, reminding us of both the fragility and resilience of existence. The Anthropic Principle bridges science and philosophy, offering insights into the interplay between empirical observation and metaphysical inquiry. Scientifically, it underscores the limitations of human knowledge, reminding us that our understanding of the universe is shaped by the conditions necessary for our survival. Philosophically, it prompts us to reflect on deeper questions about purpose, causality, and the nature of reality itself. One way to approach these dilemmas is through the lens of pantheism, which equates God with the universe itself. Rather than viewing the cosmos as a product of external creation, pantheists see divinity embedded within its very fabric. From this perspective, the fine-tuning of the universe reflects not the handiwork of a transcendent deity, but the intrinsic harmony of existence. Every star, atom, and living organism participates in a grand symphony, contributing to the unfolding story of the cosmos. This interpretation aligns with certain interpretations of the strong Anthropic Principle. which emphasize the interconnectedness of all things. Another avenue involves embracing uncertainty as a fundamental aspect of reality. The Anthropic Principle reminds us that much about the universe remains mysterious and unknowable. Rather than seeking definitive answers, we can adopt a posture of curiosity and openness, allowing wonder to guide our exploration. Whether or not the universe is designed for us, the act of questioning our place within it connects us to something larger than ourselves, a shared journey of discovery and reflection. Ultimately, the Anthropic Principle invites humility. It challenges us to recognize the limits of our perceptual apparatus, which evolved to navigate a finite, predictable environment, not an infinite, probabilistic cosmos. When faced with concepts like divine design, selection bias, or infinite universes, we strain against the boundaries of intuition, struggling to reconcile the counterintuitive with the familiar. Yet in doing so, we deepen our appreciation for the complexity and beauty of existence. As we contemplate the fine-tuning of the universe and our role within it, another profound question emerges. What if history repeats infinitely, forcing us to relive every moment over and over again? This unsettling idea is embodied in Friedrich Nietzsche's concept of eternal recurrence, a thought experiment that imagines time looping endlessly, replaying every event identically. According to Nietzsche, this eternal cycle serves as a litmus test for affirming life despite its hardships. Would you embrace recurrence, finding joy and meaning in repetition, or would you dread the prospect of endless monotony? Eternal recurrence challenges us to confront the weight of our choices and actions. If every decision spawns infinite iterations of itself, then how do we define identity and free will? Does the prospect of infinite repetition render life meaningless, or does it amplify its significance? As we explore Nietzsche's provocative vision, we will delve into the psychological, existential, and ethical implications of living in a cyclical cosmos. So, as we leave behind the delicate balance of the Anthropic Principle, let us turn our attention to the eternal loops of eternal recurrence. By examining whether history repeats infinitely, we confront not only the transient nature of individual moments, but also the enduring patterns that shape our lives. Together, these perspectives remind us that while existence may be fleeting, the echoes of our actions reverberate across eternity. Eternal recurrence, living forever in an infinite loop. Imagine living your life exactly as you have, and then doing it again and again, forever. Every joy, sorrow, triumph, and failure would recur without end, an eternal repetition of the same events, decisions, and emotions. This unsettling yet profound thought experiment is known as eternal recurrence, a concept introduced by the German philosopher Friedrich Nietzsche in his seminal work, The Gay Science. For Nietzsche, eternal recurrence was not merely a speculative idea about the nature of time, but a radical test of how one ought to live. Would you embrace the prospect of infinite repetition, finding meaning and affirmation in the cyclical nature of existence? Or would the thought of reliving every moment, especially the painful ones, fill you with dread and despair? At its core, eternal recurrence suggests that time loops infinitely, replaying every event identically. This means that the choices you make today, the relationships you form, the dreams you pursue, and even the mistakes you regret will all happen again. Not once, but endlessly. The implications of this idea are staggering, forcing us to confront the weight of our actions and the significance of our lives. If every decision spawns infinite iterations of itself, how do we define identity purpose and free will? Does the prospect of eternal repetition render life meaningless, or does it amplify its importance? As we explore Nietzsche's vision of eternal recurrence, we will delve into its philosophical underpinnings, examine its existential implications, and consider what it means to affirm life in the face of infinite cycles. To fully appreciate the depth of eternal recurrence, we must first understand it as more than a mere hypothesis about the nature of time. While some interpretations frame it as a literal cosmological theory, suggesting that the universe operates in an endless cycle of expansion and contraction, Nietzsche primarily intended it as a metaphorical tool for ethical reflection. He posed the question, what if a demon whispered to you in your loneliest hour that you must live your life over and over again, exactly as it has unfolded thus far? Would you curse the thought, burdened by the weight of past mistakes and hardships? Or would you welcome the prospect, embracing the beauty and tragedy of your existence with equal fervor? For Nietzsche, the answer to this question reveals whether one has truly affirmed life. In his view, many people live reactively, driven by fear, resentment, or the desire for comfort. They avoid pain, cling to fleeting pleasures, and fail to confront the harsh realities of existence. Eternal recurrence challenges this reactive stance by forcing individuals to take full responsibility for their lives. If every action will recur infinitely, then every choice matters profoundly. To embrace recurrence is to say yes to life, not just the joyful moments, but also the suffering, the uncertainty, and the impermanence. It is to live authentically, with courage and intention, knowing that your actions resonate eternally. This perspective aligns closely with Nietzsche's broader philosophy, particularly his concept of the Übermensch, overman, and the rejection of traditional morality. The Übermensch represents an individual who transcends conventional values, creating their own meaning in a world devoid of inherent purpose. Eternal recurrence serves as a litmus test for this transcendence. Only those who can affirm life in its totality, without reservation or regret, are capable of embodying the Übermensch's ethos. By confronting the infinite repetition of existence, one learns to embrace the present moment fully, transforming life into a work of art rather than a series of obligations or regrets. The implications of eternal recurrence are as vast as they are paradoxical. On one hand, the idea fills many with terror, evoking a sense of claustrophobia and inevitability. If every moment recurs infinitely, then there is no escape from the consequences of our actions. Every triumph carries the shadow of eventual loss. Every failure echoes endlessly through eternity. The weight of this realization can be crushing, especially for those who harbor guilt, shame, or unresolved pain. How does one find peace in a cosmos where nothing is forgotten and everything repeats? Yet for others, eternal recurrence offers liberation rather than despair. By accepting the cyclical nature of existence, one can break free from the illusion of linear progress and the pressure to achieve permanence. In a finite lifespan, we often strive to leave a legacy, to ensure that our contributions endure beyond death. But what if such efforts are unnecessary? What if the true measure of a life lies not in its lasting impact, but in the intensity and authenticity of its lived moments? Eternal recurrence invites us to focus on the here and now, to savor each experience as if it were both the first and the last time it would occur. Philosophically, eternal recurrence also raises questions about free will and determinism. If every event recurs identically, then do our choices truly matter? Are we passive participants in a predetermined script, unable to alter the course of history? Or does the act of choosing retain its significance precisely because it shapes the eternal pattern of our lives? These tensions highlight the dual nature of the concept. It can inspire both fatalism and empowerment, depending on how one interprets it. Psychologically, eternal recurrence challenges us to confront our relationship with time. Human beings tend to think of time as a linear progression, a journey from birth to death, marked by milestones and transitions. Yet Nietzsche's vision disrupts this framework, suggesting that time is not a straight line, but a circle. This shift in perspective forces us to reconsider how we allocate our attention and energy. Instead of fixating on future goals or dwelling on past regrets, we are encouraged to inhabit the present fully, recognizing it as the only point of contact with eternity. While Nietzsche framed eternal recurrence as a philosophical and existential challenge, modern physics offers intriguing parallels and contradictions to this idea. Some cosmological models propose that the universe operates in cycles, expanding and contracting repeatedly in what is known as the oscillatory universe hypothesis. According to this theory, the Big Bang is not a singular event, but part of an endless sequence of cosmic rebirths. Each cycle begins with a period of rapid expansion, followed by a gradual slowdown as gravity pulls matter back together, culminating in a big crunch that resets the process. In this scenario, time itself might loop infinitely, creating conditions for eternal recurrence to occur. However, other theories paint a bleaker picture of the universe's fate. One widely accepted model predicts that the cosmos will eventually succumb to entropy, leading to a cold, dark state known as heat death. As stars burn out and galaxies drift apart, the universe will reach a state of maximum disorder where no usable energy remains to sustain processes like life or consciousness. Unlike eternal recurrence, which envisions infinite repetition, heat death represents a terminal endpoint, a final silence that extinguishes all possibility of renewal. These contrasting visions highlight the tension between cyclical and linear conceptions of time. On one hand, eternal recurrence suggests that existence is a closed loop, where every ending gives rise to a new beginning. On the other hand, heat death implies a one-way trajectory toward dissolution, where the universe exhausts its potential and fades into oblivion. Together, these perspectives underscore the fragility of order in a chaotic cosmos, reminding us of both the resilience and impermanence of life.